This lesson deals with Supplemental Problem 4.2. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 2. In this supplemental problem, we're going to take a look at a 2N5462 P-channel JFET, and you can find the datasheet for this in the reference at the bottom of this page, which is the Motorola Semiconductor Data Library, Volume 2 of Discrete Products, Series A, on page 2-169. In fact, let's pull that up. Here's the datasheet of that P-channel JFET. There's 6 of them here. You can see that 3 of them have ratings that are different than the other 3. So these are maximum values of different parameters. Let's take a look at the electrical characteristics and find the parameters we need. Our pinch-off voltage is actually this term here, the gate source off voltage. And they're giving a range of values, a max and a min. We could take the average of this and get roughly a typical value. If you add these two together, you'd get 10.8. Divide that by 2, you get 5.4. Now our pinch-off voltage, as we defined it for P-channel devices, is a negative number. A lot of times in data sheets, you'll just see positive numbers just giving you the magnitude. And then we're looking for the term I sub SDS. Here they're giving I sub DSS, which is actually would be a negative number. But again, they show it as a positive, and they give a range of max to min. So if you add these two together and divide by 2, you get 20 divided by 2, or 10 milliamps. So that'd be the value of our I sub SDS. And that's what I've listed over here, based on an averaging of the max and the min. For what range of values of the source to drain voltage does this device remain in the saturation region if the source to gate voltage is -2? I've shown the schematic symbol here for a P-channel JFET, putting the source on the top and the drain on the bottom because current is going to flow this way in the transistor. And that's typically how things are shown in schematics and data sheets and hobbyist magazines. Label the voltages from source to gate, source to drain, and then from drain to gate. To be in saturation or current saturation, the source to gate needs to be greater than or equal to pinch-off, and the drain to gate needs to be less than or equal to the pinch-off. What is the drain to gate voltage? Let's just go around the loop here. The drain to gate voltage is minus the source to drain plus the source to gate. We know the source to gate is -2, and then all this has to be less than or equal to the pinch-off, which is equal, on the average, to be minus 5.4. And now we can solve for this quantity here. Let's put that on the other side of the equation. It's going to give me a greater than or equal to, and then a plus 5.4, and then a -2, and that's 3.4. And this is supplemental problem 4.2.